Try it right now, wherever you are. Run your fingers along your own ribs, your neck, the bottom of your foot. Nothing. Maybe a faint pressure, but not the helpless, squirming, laughing kind. Now imagine someone else doing the exact same thing. Your whole body already wants to flinch away. Same fingers, same spots, same nerves underneath. So why does one make you laugh and the other does nothing at all? This is one of the oldest questions about the human body. Aristotle wrote it down more than 2,000 years ago. He noticed that humans seem to be the only creature that laughs, and that no one can tickle themselves. He could not explain it, and honestly, neither could anyone else for the next 20 centuries. It seems like a trivial question, the kind a child asks and adults wave away, but the harder you look at it, the deeper it goes. The answer turns out to hide something genuinely strange about how your brain works. Your brain is not actually showing you the world as it happens. It is showing you a prediction of the world, made a heartbeat ahead of time. Let's start with the obvious guess, the one most people land on. You might assume you can't tickle yourself because you know it's coming. There's no surprise, so there's no reaction. That feels right. And Charles Darwin thought something close to it back in 1872. He argued that tickling needs the unexpected and a certain light, playful state of mind. But surprise alone can't be the whole answer, because even if a friend warns you exactly where and when they'll tickle you, it still works. You can see the hand coming, count down to it, brace yourself completely, and the moment it lands, you crumble anyway. In fact, you often start laughing before the fingers even touch you. The anticipation alone is enough, which tells you the reaction isn't really about the contact. So it isn't really about knowing, it's about who is doing the moving. Your brain treats your own actions completely differently from everything else in the world, and it has a very good reason to. To understand why, you have to look at what your brain does every single time you move a muscle. This is where the real mechanism lives, and it's beautiful. Every time your brain sends a command to your hand, it secretly keeps a copy of that command. Scientists call this copy an efference copy. With that copy, your brain runs a quiet little simulation of what's about to happen. It predicts exactly what your fingers will feel before they feel anything. Engineers call this kind of thing a forward model, and your brain runs one constantly. It is the same trick that lets you carry a full cup of coffee without watching your own hand. And here is the key move. Whatever sensation your brain successfully predicts, it turns the volume down on. The prediction and the real touch cancel each other out. This canceling is why your own touch feels muffled and dull. Your brain saw it coming, in the most literal possible sense, and quietly subtracted it. This is happening every waking second, far beneath your awareness. The pressure of your own clothes, the feeling of your tongue resting in your mouth, all predicted and dialed down to nothing. The part of the brain running this prediction is the cerebellum. It sits at the back of your skull, and it's essentially a prediction engine. It is constantly forecasting the sensory consequences of your own actions. When the forecast matches reality, the sensation gets dampened down to almost nothing. A tickle from someone else arrives with no forecast attached. Nothing predicted it, so nothing gets subtracted, and the signal hits you at full strength. That full-strength jolt to a vulnerable spot is what makes you yelp and laugh. For a long time, this was just an elegant theory. Then, in the late 1990s, 3 researchers at University College London decided to test it directly. Sarah Jane Blakemore, Daniel Wolpert, and Chris Frith built a small tickling robot. The setup let a person move a lever that, in turn, moved a soft foam tip across their own palm. So you were tickling yourself, but through a machine. And just like real self-tickling, it barely registered. But then they did the clever part. They started adding a tiny delay between the moment you moved the lever and the moment the foam touched your hand. 1/10 of a second, then 2, then 3. As the delay grew, something remarkable happened. The touch started to feel ticklish again. The longer the gap between your action and the sensation, the more it tickled. They even tried rotating the direction, so your hand moved one way and the touch went another. That brought the tickle back too. What they had found was the prediction breaking down in real time. The moment your brain's forecast stopped matching what your skin actually felt, the volume came back up. They could literally dial your ticklishness up and down by messing with the prediction. When they scanned people's brains during all this, the cerebellum lit up exactly as the theory said it should. The better the brain could predict the touch, the quieter the response. Prediction was the dial, and the cerebellum was the hand turning it. This is one of the cleanest demonstrations in all of neuroscience that you live inside a prediction. It's worth pausing on how odd that really is. The reason you can't tickle yourself is that your brain is always one step ahead of your own body. It has already guessed what you're about to feel before the nerves report in. Now, tickling itself is stranger than it first appears, and it comes in two flavors. Back in 18, two psychologists named G. Stanley Hall and Arthur Allen gave them names. The first is kinesmesis, the light, feathery, itchy kind. That's the one you get from a bug crawling on your arm or a strand of hair. You can actually produce a faint version of this one on yourself. Hoist yourself. The second kind is gargalesis, the heavy, helpless, laughing tickle. That's the ribs and armpits and the squirming and the begging them to stop. And gargalesis is the one you absolutely cannot do to yourself, no matter how hard you try. Which raises a question that bothered researchers for a while. Is that laughter actually a social thing, or is it just a reflex? Christine Harris at the University of California tested this in a pretty sneaky way. She convinced people they were being tickled by a machine, not a person. If the laughter were purely social, a cold machine shouldn't get one out of you. But people laughed at the machine just fine. That suggested the response is wired in deeper than mere social play, closer to a reflex. It sits somewhere between a reflex and a conversation. Your body, it seems, will laugh at the touch whether or not anyone's there to enjoy it. The puzzle gets bigger when you look beyond humans. It turns out we are not the only animals that crumble under tickling. The neuroscientist Jaak Panksepp made one of the most charming discoveries in his field. He found that rats, when tickled on their bellies, produce a stream of high-pitched chirps. These chirps sit far above what we can hear, but recorded and slowed down, they look a lot like laughter. The rats would even chase his hand, apparently asking for more. Some rats even let out their chirps just from seeing the hand approach. The young, playful ones were the most ticklish of all. And here's the part that fits everything together. Those rats can't tickle themselves either. Panksepp tied the whole thing to the brain's ancient circuits for play. Tickling, in this view, is a kind of play fighting that builds social bonds. Notice where your most ticklish spots actually are. The neck, the ribs, the belly, the armpits, the soles of your feet. Those are exactly the soft, vulnerable places you'd instinctively protect in a real fight. One idea is that tickle play is practice for defending your most fragile zones. The laughter is the signal that says this is just a game, not a genuine attack. If the way your brain quietly edits your reality is starting to fascinate you, the rest of this channel runs on exactly these kinds of questions. Now we come to the strangest finding of all, and it's a little unsettling. Remember that the whole trick depends on your brain correctly tagging an action as your own. Your cerebellum predicts the touch, knows it's coming from you, and cancels it. But what happens when that self-tagging system breaks? Sarah Jane Blakemore went on to study people living with schizophrenia, and she found something remarkable. Some of them can tickle themselves. For them, a self-generated touch doesn't get dampened the way it does for everyone else. The leading explanation connects this to the same system that tells you which thoughts and actions are yours. When that system falters, your own movements can start to feel like they came from somewhere outside you. It's thought to be related to why some people experience their own inner voice as a voice belonging to someone else. The failure to cancel a self-tickle and the sense that your thoughts aren't your own may share a single broken mechanism. Suddenly, a silly party trick becomes a window into how the brain holds on to a sense of self at all. The line between you and not you is drawn in part by this quiet little prediction engine. It is humbling that something so fundamental rests on a mechanism you never feel working. You only notice it in the gaps when the prediction fails. Researchers have even tried to outsmart the system on purpose. A team in Australia used a body swap illusion to make people feel they had taken over someone else's body. The idea was to slip a self-touch past the prediction by scrambling the sense of whose body it was. If prediction were really the whole story, that confusion should have brought the tickle back, but it didn't work. Even while feeling like they inhabited another body, people still couldn't tickle themselves. The attenuation held firm, which hints the cancellation runs deeper than context alone. To tickle yourself, it seems, you may need to fool something far harder to fool than your eyes. So step back and look at what this little impossibility is really telling you. You cannot tickle yourself because you cannot surprise yourself. And you cannot surprise yourself because your brain is forecasting your every move a fraction of a second early. The world you feel is always shaded by what your brain expected to feel. Most of the time, that prediction is so good you never notice it's there. The failed self-tickle is one of the rare moments the trick slips into view. It's a tiny crack in the screen showing you that there's a projector behind it. Darwin thought it was about surprise, and Aristotle just thought it was weird. Both were circling the same truth without the tools to name it. You are not feeling the world directly. You are feeling your brain's best guess about the world, corrected on the fly. So here's the thought worth sitting with. If your brain is quietly erasing the sensations it sees coming, then the only things you feel sharply are the things it failed to predict. Which means everything that surprises you is, in a sense, the only part of reality you ever truly touch.